gathering data on destructive tornadoes in the field to cutting-edge advancements in warning technology. We celebrated our 60th anniversary and were featured in a Hollywood movie. 2024 was a banner year for NSSL. Our lab is home to an incredible team of research scientists, engineers, and staffers who passionately pursue our mission to better understand, observe, and predict severe weather. Let's take a look at some of the highlights of our major research programs from this year.
Studying tornadoes has been at the heart of our mission for more than 60 years. Much of that work falls under the VORTEX-USA program. This year, researchers under VORTEX-USA collected data from 13 severe weather events in the Southwest, Midwest, and Great Plains as part of the Delta and Lift field experiments. These large-scale experiments put dozens of scientists and a wide range of vehicles, computing, and instrumentation out into the field to study tornadoes up close. Gathering these observations and ground truths are an essential part of nearly all the research that happens at the lab. Additionally, NSSL analyzed more than 18 hours of interviews with National Weather Service forecasters, broadcast meteorologists, emergency managers, and members of the public from the devastating Rolling Fork and Amory, Mississippi tornadoes of 2023. Vortex also supported the FEE demonstration project, in which more than 10 NWS forecast offices used and evaluated real-time, experimental, severe weather probabilistic hazard guidance. Another step toward moving this groundbreaking technology to operations. This wealth of data and hands-on demonstration will be critical to the work of understanding how tornadoes form in the southeastern United States, how the public receives and reacts to severe weather information, and how we can improve warning and lead times, especially for vulnerable communities in this region. 2024 was a banner year for NSSL's radar research and development. We made significant improvements and refreshes to the Advanced Technology Demonstrator, NSSL's research dual-pole phased array radar, including replacing the radome and generator along with upgrading servers. These improvements will enable new scanning and technical abilities for conducting new science and engineering. Even during these upgrades, the work of collecting data carried on. NSSL captured more than 146 hours of meteorological data on various modes of weather events, giving a robust range of cases for evaluation. This data is crucial to moving PAR technology forward in its development as a potential solution for the National Weather Service's Radar Next program. 2024 also saw the lab begin initial implementation of adaptive scanning techniques and spoiled beam scans on the ATD. Adaptive scanning identifies storm locations and changes the update rate based on the presence of those storms. Spoiled beam scans use a wider transmit beam than normal, with multiple simultaneous receive beams to collect data faster. Perhaps most importantly, NSSL also released a 5-year PAR research and development plan that will be a roadmap for our research and engineering priorities through 2028 as we continue to develop the weather radar technology of the future. In 2024, NSSL completed nearly 100 warn-on-forecast domains over the course of 69 days in collaboration with NWS National Centers. These WAFS runs supported operations for severe weather, flash floods, fire weather, and hurricanes, including Helene and Milton. Additionally, the lab completed a multi-year assessment of a 1-kilometer WAFS prototype. This research quantifies what could be gained by moving WAFs to higher resolution, such as better prediction of supercells and their rotation intensity, all ultimately leading to better information for forecasters and the public. As NSSL continues to improve and push warn-on-forecast forward, it is also preparing to transition the system to NWS operations. 2024 saw the completion of the WAF's transition plan that received initial signatures, with full signatures expected by early 2025. NSSL has already accomplished one of the milestones in the plan by gathering all published best practices for using WAFs, with the intent to develop a training plan for forecasters in collaboration with the National Weather Service. Over the years, NSSL has continued to push the boundaries of scientific understanding of tornadoes and severe weather. These efforts have led to cutting-edge technologies that have improved forecast and lead time. Yet we also know this information is only useful if it is accessible and easily understood by the people who need it. NSSL's social and behavioral science team works to find ways to make severe weather information more effective for the end user. In 2024, we submitted publications on topics ranging from interpretation and use of threats in motion data to NOAA hazardous weather testbed experiment analysis. We also rolled out version 2.0 of our Tornado Tales Weather Survey. Tornado Tales gives citizens the opportunity to report their experience with tornadoes and severe weather, giving researchers insight into how the public receives, understands, and acts on watches and warnings under various circumstances and conditions. Better understanding how the public interacts with weather information is critical to improving communication of severe weather risks and threats. Even with all the major science accomplishments highlighted so far, we're really just scratching the surface of the cutting-edge innovation happening here at NSSL. We're using an LED array brighter than the sun, combined with high-resolution and super high frame rate cameras to capture images of falling hail before impact. This will help shed light on how hailstones behave as they fall, leading to improvements in forecasting, detecting, and warning for hail. NSSL is using uncrewed aerial systems to gather environmental data around storms, getting closer and being more nimble than is possible in vehicles on the ground. Those same systems are also being used to conduct damage surveys after tornadoes, giving us insight into wind speeds, patterns, and damage at the surface, an area of tornado science that is still relatively new. Wildfires continue to become a bigger problem in the United States, and we are using mobile radars to learn how wildfire impacted landscapes, burn scars, and precipitation can lead to damaging debris flows and flash floods. This data helps to improve our understanding of the rainfall runoff process and equipped forecasters to better predict and warn for these damaging events. As artificial intelligence and machine learning continue to develop at an astonishing pace, our scientists are putting those tools to work in a myriad of ways across the lab. Utilizing these tools expands the capacity of our scientists and accelerates the pace of discovery and innovation. And we even had a bit of fun this year with the release of Twisters. NSSL researchers were consulted by the filmmakers for scientific accuracy and prop development. We even produced our own educational content to highlight the real science of tornado research. With another stunning year of achievement in the books in 2024, all of us here at the lab and our partners at CIRO who work collaboratively with us to achieve our goals are already hard at work, building off that success and looking forward to what 2025 has in store. Because even after celebrating 60 years of achievement and discovery, we're only just getting started.